right, welcome back. So today we are going to be demonstrating CPE 133, lab number 1. So our assignment was to basically make a lockbox that has four 4-bit inputs, and the lockbox will open for the values listed right there: 5, 6, 7, 9, 11, 10, 11, 13, 14, and 15. Basically, we're gonna make this Basis 3 board comply to those constraints. So what we have is, here, let me open up Vivado. Let's see, let's go to right here. So here in Vivado, we have listed our inputs A, B, C, D, and our outputs Q1 and Q2. And basically we have two outputs to show the product of sum output, which is listed right there, A or B, and C or D. And we also have the NOR implementation, the NOR line of code right there, which will do the same exact thing, have the same output, but just get to the outputs through only using NOR gates. So let me back up. So this is so in order to run the simulation, we have right here, we're using a for loop to run through all 16 values. And yeah, so I'm now going to be demonstrating the board, what's gonna pop up on the board, and it would be a good idea to have the truth table right here to verify that we have done this correctly. So as before, we have so 4 inputs A, B, C, and D. It's gonna be flip-flops, so A is gonna be right here, B is right here, C is right here, and D is right here. And we have LED 1 and LED 2 right here, which are gonna represent the outputs. The POS for LED 0 and LED 1 is gonna be the NOR outputs. So let's get started. So we have all zeros, and we expect neither lights to be on, and we can verify that. If we flip switch D on, nothing, the lights will stay off. So A, B, C, D, lights are still off. And now for the next one, we just have C on. So flip D down, put C on, still nothing, okay. And then for index 2, we have, we're on index 3 now. We have C and D on. Already have C, flip D on, and we still expect none of the lights to turn on. So now let's flip B on and C and D down. So we're gonna flip B up, C and D down, and we have both lights off. Now we are gonna leave B on and turn D on, and we expect the lights to flip on as well, and they do. Awesome. And now we want to flip D down and flip B up, which is gonna have the 0, 1, 1, 0, and we still expect the lights to be on. D down, B up, yes it does, good. So we have, we just went through index 6, 0, 1, 1, 0, and now let's go through index 7, 0, 1, 1, 1, meaning that all of them except A are on. Flip this one up, and they're still gonna be on. 0, 1, 1, 0, or no, 0, 1, 1, 1 is gonna have the lights on. Now we flip all 3 of the switches off, and let's flip A on. So all switches are off, A is on, and we do not have any of the lights on. 1, 0, 0, 0, and we expect a 0. Or we expect none of the lights to be on. So now let's have A on and D on. So flip D up, and the lights go on. Does that match? 1 0 0 1. Yes, it does. So let's move to 1 0 1 0. We expect the light to be on as well. So 1 0 1 0. The lights remain on. Perfect. 1 0 1 0. Great. Now we have 1 0 1 1. 1 0 1 1. Lights are still on. 1 0 1 1. Great. Now we have 1 1 0 0, and we expect the lights to switch off. So A is on, B is on, C and D are both off. And awesome. So that's great too. And then for index 13, we have 1 1 0 1. So we leave these two up and flip D on, and they turn on. Great. And wait for it to focus. Okay. So we got 1 1 0 1. Now we're going to do 1 1 1 0, meaning that we flip D off and C on. And does that line up with what we expect? 1 1 1 0. Yes, it does. And last but not least, we have the final situation where we have the final combination, which is all of them on, and we expect the light to stay on. Perfect. So if you can't tell, we got all the switches up, and that confirms that the basis board matches the outputs that are expected for all possible inputs for the lockbox. So thank you for watching, and see you next time.